Hi, this is Nirmala Rednam. In this video, we are going to solve the sums from exercise 6.1 and 6.2. Let's start with the try these section. The first try these section, they're asking us find the ones digit of the cube of each of these following numbers. Now, I've already told you whenever we are interested in the cube of a given number, all we need to look at is the ones digit over here. So because one cube is 1, so the cube of this entire 4-digit number is going to be 1. Now what is 8 cube? Here I have 8, so I'm interested in 8 cube. 8 cube ends in 2, right? Because 8 8 64 and 4 into 8 will give you 32. So that is the answer. And here 9 square is 81. 81 into 9 will have 9 in the ones digit. So that is our answer. Here it is going to be 5. And here it is 4 again, because 4 square is 16 and 6 4 is 24. And here you will have 3, because 7 square is 49 and 9 into 7 is 63. And here 2 cube is 8, so I have 8, and here I will have 7 because 3 cube is 27, so it ends with 7. So that is our try this question. Next, we have looked at this pattern and I've told you how to determine the first odd number that you need. So here if you see, express the following as sum of odd numbers. Because I have a 6 here, I'm going to say 6 into 5 is 30. 30 plus 1 is 31. So I'm going to write it as 31 plus 33 plus 35 plus 37 plus 39. So you can see that I have 6 consecutive odd numbers over here. So this should give me the answer, which is nothing but 216. Sorry, this makes only 5 of them. I'm going to add the next odd number. Now you can check there are 6, and if you add them, actually the answer is going to be 216. I am not calculating because it's noted, in the sense, like I said, the cubes of at least first 10 if not 20 should be noted to you, but if you add them and check, it's going to be the correct answer. Next I have 8 into 7 is 56 plus 1 is 57. So from 57 I will write down 8 odd numbers. Okay, so this is 4. I'm going to write in the next line. I have 5, 6, 7 and 8. So this is the value of 8 cube, and the answer is going to be 512. You can check it. 8 cube is 512. Next I have 7. So I'm going to start with 7 into 6, 42 plus 1, 43. So I will start with 43. I'm going to write down 7 odd numbers. And what is the sum going to be? It is going to be 343. Now here I have written 53 twice. It's 53 plus 55. Okay, like I said, I am writing the answers from memory, but if you want, you can check the sum of these 7 odd numbers. It is going to be 343. And then this pattern, we have already noticed that this is nothing but, so this is going to be 1 plus 7 into 6 is 42, 42 into 3. Okay, so 7 into 6 into 3, and this answer is 127. So that is what 7 cube minus 6 cube is going to be. Next I have 12 cube minus 11 cube. So this is going to be 1 plus 12 into 11 into 3. Now what is this product? This is 36. 36 into 11 is going to give you 396. So this is 397. Right? Next I have 1 plus 20 into 19 into 3. Right? And 20 into 3 is 60. So 19, 6 is 114. and I have plus 1, so this is 1141. Okay. Next is 1 plus 51 into 50 into 3, right? So here I have 150, 150, 15 into 51, you can check, 51 into 15, I have 76. So I have to put a 0 plus 1 and it will become 7651. So you can see that once you observe the patterns, how you can calculate such expressions without actually calculating 51 cube, 50 cube and all those big numbers. So that is one way of solving sums when you have an expression like this and you can see a pattern. This you will in when you come to algebraic expressions, this is a cube minus b cube like I said, and it is going to be very obvious to you then, right? And solved examples, please go through. And then I have one more try these here. Which of the following are perfect cubes? Now how do you check that? I told you, you have to do prime factorization in order to check which of the following are perfect cubes. So let's do that. The first question is, let me put the heading exercise. Oh sorry, this is the try this question, it's not the exercise. So in the try this question, the first number that we have here is 400. So let me do the prime factorization. 400 gives you, and this is 5 into 5, right? So here I have 400 can be written as 2 into 2 into 2 into 2 into 5 into 5. Now I need to try and group them as groups of 3, right? So you can see that this group is fine, but here I cannot group this or this. So the answer to the question, what are they asking? Which of the following are perfect cubes? So clearly this is not a perfect cube. 400 is not a perfect cube. So you're not going to mention this as a perfect cube. Next, second number that they gave is 3375. Okay, so let's do the prime factorization. Here I have, again I'm going to take 5. One more time I'm going to take 5. This time I'll take 3. So you can see that the given number is nothing but 3 into 3 into 3 into 5 into 5 into 5. So clearly you can see that you can group them into groups of 3. Therefore, it is a perfect cube, right? Next, let's go to the third number they have given, 8,000. So if I have to factorize it, I'm going to start with 2. Okay, it's a big number. It's going to be lengthy. In a while, I'll tell you how to make sure that you don't spend too much time on this factorization. But for now, just let's just do it this way, right? 5 25s and then 5 square. So here I have into one more set of 2s and then one set of 5s. So clearly you can see that I have 3 groups of 3, and so it is a perfect cube. Next, coming to the fourth question, 15625. Okay, because I have a 5 immediately, I'm not going to bother checking 3, because if it happens to be a factor anyway, we will come to it later. I'm going to directly go to 5. Okay, so I have 3125 6, 2, 5, 1, 2, 5, 25 and 5. So you can see that I have 6 5s here. That makes it two groups of 3, and therefore it is a perfect cube. Okay. The fifth number they have given is 9,000. Okay. So here I'm going to take 2250. We're going to get a lot of 2's here. 1125. And now I'll go to 5. 225, 45 and 2 3's. Therefore here I have only 2 3's. Okay. So that is going to be a problem. And so it is not a perfect cube. Next number they have given is 6859. Okay. So 6859, clearly 2 is not a factor. You can check 3, 14 plus 14, 28, not a factor. And then we will go to 5, 5 is not a factor. 7, you can check that it's not a factor. 7, 9, 63 and then 55, 49 and 69 won't go. So 7 is also not a factor. And then you can check 9, sorry not 9, 11, and you will see that even 11 is not a factor for this number. And then you will go to after 11 you have 13 and then 17 and 19. So it turns out that 19 is a factor of this number. Okay, so you have to check all the prime numbers starting from 2 up to 11. You're already familiar with the divisibility rules. After that you need to actually do the division in mind or on rough sheet and check. So for 19 I have got 19 threes is 57, and then I have 1 4 1 1 5, right? So I'm going to write 19 6, right, which is 114 and then 1, and 361 you already know is 19 square. Okay, so this happens to be 19 cube. So it is in numericals like these that having the first 20 squares and cubes noted is going to be really helpful and going to save a lot of time for you. So this is a perfect cube. Next is 2025. I'll go to 5 because I have a 5 in the ones place. So I have 405 and 81. Then 3. 27. 27 is 3 cube. So clearly you can see that this is not going to work out. I have only 2 5's and I have even the 3's are not pairing up. I have a single 3 left out. So this is not a perfect cube. Next number that they have given is 10648. So it's a 5-digit number and it is an even number. So I'll start with 2. 5 3 2 4 2 6 6 2, right? 1 3 3 1. Now here again, like I said, if it's noted to you already, then you'll see that this is actually 11 cube. Otherwise you have to check starting from 2 3 5 7 and then 11. 11 ones, 2's, 1's, and this is 11 square. So this seems to be a perfect cube. I have 3 2's and 3 11's, right? So this happens to be a perfect cube. So that is about the try these question. So here let us see what is the next question. Please go through the solved examples, and the next is think, discuss and write. They're asking us check which of the following are perfect cubes, right? And you can see that they have given, if you go to the ninth one, you can see that it's a pretty big number, right? So clearly they are not expecting you to do the prime factorization as we do traditionally. Okay, they want you to think about it. And one more thing you can notice here is that there are a lot of zeros in the end. For each of these numbers that they have given, there are a lot of zeros. Okay, so for this, what we are going to do is, first we are going to think about, is there any faster way in order to check whether it's a perfect cube or not. For this, I want you to recall, if you remember, in the squares, we have concluded that whenever you have even number of zeros, right, then there is a possibility. Odd number of zeros, there is not, it's definitely not a perfect square, right? Remember? So here, if you see that, here I have only two zeros, okay? And here I have only two zeros. Here I have only two zeros. And here again I'm having four zeros, okay? So what I'm suggesting is, for a perfect cube, I need set of 3, right? So if you look at this number 10, now 10 is nothing but 2 into 5. Although 10 is not prime, it is prime of two distinct prime numbers, right? So if I am having a 0, it is not going to be able to pair up. There is no possibility here. Okay, so I will need another 10 in order to pair it up in the case of square, right? In the case of a cube, I need one more 10 in order to pair it up as a set of 3. Okay, think about it. If you remember, till now I kept on warning you or cautioning you that you should always make sure that you are doing a prime factorization, as in product of prime numbers. So we have been doing that, we have been sticking to that rule, so on. But what I'm saying is, if at all you have the number of zeros in the end, which is not a multiple of 3, as in the case of 1 and the 4th number here and the 7th number and the 8th number here, then you can conclude that it can't be a perfect cube. Okay, so I need you to carefully consider what I'm saying and think about it. Why are we saying that? Okay, so this is definitely not a perfect cube. So is this, and this one as well, and this one. These four numbers are definitely not perfect cubes because we don't have 3n number of zeros. I need 3n as in any multiple of 3. Okay, I don't have 3n number of zeros, therefore I am concluding that it is not a perfect cube. Okay, so now what we're going to do is check for the rest of them. So I have 16,000, right? So 16, once I have these, 10 cubes sorted out, I know that 10 cube root will give me 10. Is 16 a perfect cube? It is not. Because 16 is not a perfect cube, this number can't be a perfect cube. Okay. Now, if I have, if I have this sorted out, that is the zero sorted out, then I'm going to check this, because in the end it's just a product. I can write a into b as b into a and rearrange the factors here and there to confirm that whether it is a perfect square or not. Now if you come to the third question, I have 10 cube. If you look at 64,000, I have a 10 cube. I'm happy about that because this will give me 10 in the cube root. And what about 64? Can we write it as some cube? It is 4 cube, correct? 4 cube is nothing but 64. Therefore, this is a perfect cube. So this is one way of looking at it. Try to write the given number as product of familiar, especially when you have zeros, you can divide it up. I mean, you can break it down. Whenever you have zeros, you can break it down and check. So here again 125, 3 zeros. Now again, because it's 3 zeros, I am glad about that. What about 125? It is 5 cube, right? 5 5 is 25 and 25 5 is 125. Therefore, this is going to give me the cube root as 50. So this is not a problem. right? And then coming to this, you can clearly see this is 10 cube, not an issue. 36 is not a perfect cube. Therefore, this is not a perfect cube. And if you come to this, you will see that there are two sets of 3. Good enough. I'll get, I will have 10 square in the, 10 cube into 10 cube. So when I take the cube root, it will give me 10 square 100. And what about 27? It's nothing but 3 cube. Therefore, this will be a perfect cube. 1000 is 10 cube. Therefore, it is a perfect cube. So you can see that of the given numbers, it's pretty messy here. I'm going to list it down. 64,000 is a perfect cube, right? 125,000 is a perfect cube. And 27 million is a perfect cube, and 1000 is a perfect cube. So these are the 4 numbers out of the 10 numbers given to us which are perfect cubes. Now it's very important that you understand why they're asking you this question, as in what is the observation that you're making here, because in the exercise there are going to be a lot of big numbers, and I want you to think a little a little more than just blindly prime factorization, in order to shorten the time taken to solve the sum. As in, whenever this, like I said, the logic here we are using is 10 is a product of 2 different prime numbers. So I'm going to first write it as 10 and then we'll proceed from there. Similarly, in the exercise I'll be telling other numbers which you can during the factorization, although it is not a prime number, we will go ahead with it and then we will see, and you can break it down later if it is required. Okay, so with that, the try these of 6.1 are done. So what we will be doing is, in the next exercise, in the next video, I will show you exercise 6.1 and exercise 6.2. 6.2 has only 2 sums, so we should be able to do it very quickly. So that we'll be doing in the next video.